have access of all the subjects anytime, anywhere. And then notes are also provided. That is basically CBMB based question answers MCQ, and also full zone for self-assessment. Then MCQs are also being provided from beginner level to expert level that contain standard multiple choice questions. Then also student can book a slot for personalized counseling sessions. And we have some plans starting from basic to premium. So basic plan is of 3 months, standard plan is of 6 months, and premium plan is of 12 months. Premium plan cost around 50,000, and also it includes all the services that is provided by Auricle, like pre-recorded class, live doubt clarification, one-to-one personalized guidance, notes, quick revision examination module. And also for instant 50%, 20% discount, you can use my code, that is Aanchal 20. Then the internal exam marathon series has some core feature like rapid revision of all the important topics. Volatile facts will be discussed here. Then multiple choice questions will be covered, and also we assure top notes grades in exams, right? Then let's not waste the time and discuss some main features of Auricle. So the question to be covered are saliva composition, function, and saliva regulation. Then we're going to discuss about the stages of deglutition and sulcocentricus composition and function we're going to discuss. Then function of large intestine and defecation reflex. So these are the important topics that we are going to cover in today's class. So first, let's discuss the saliva composition. So as we know, the saliva is present in the mouth cavity, right? So mouth is also known as oral cavity, buccal cavity. And when we talk about saliva, so in human, saliva is secreted by 3 pairs of major salivary glands, and also in saliva production, some minor glands are also there, right? So when we talk about major salivary glands, so we have parotid gland, submandibular gland, that is also known as submaxillary, and sublingual gland is there. And in minor salivary gland, we have other gland like lingual serous glands, lingual mucus gland, buccal gland, labial gland, palatal gland. Various glands are there, okay? But here we're going to discuss about the properties of saliva, means composition. Okay. So whenever we talk about composition, so in volume, the saliva is secreted from 1000 ml to 1500 ml secreted per day. And that is approximately 1 ml per minute. Right? And when we talk about the contribution, so the submaxillary has the maximum contribution. 70% is secreted by submaxillary, 25% is secreted by parotid, and sublingual secrete 5%, right? And when we talk about pH, so the saliva pH range from 6.35 to 6.85. And also the specific gravity is there. So the specific gravity range from 1.002 to 1.012. And talking about the tonicity, so the saliva is hypertonic to plasma. Then another thing, that what is the basic composition of saliva? So as we can see in the slide, that saliva, majorly the water content is present, that is 99.5%. Then rest 0.5% are solids are present. So in solids, we have organic substances and inorganic substances, and some gases are there. So in organic substances, we have several enzymes like amylase, that is also known as styrene, maltase, lingual lipase, lysozyme, phosphate, carbonic anhydrase, and kallikrein. And all these enzymes are responsible for performing a specific function, right? Then in other organic substances, we have the substances like mucin, albumin, proline-rich proteins, lactoferrin, IgA, blood group antigen, free amino acids, non-protein nitrogenous substances like urea, uric acid, creatinine, xanthin, and hypoxanthins. And also in inorganic substances, we have substances like sodium, calcium, potassium, bicarbonate, bromide, chloride, fluoride, phosphate. And in gases, it includes oxygen, carbon dioxide, and nitrogen. So this is all about the composition of saliva. And also the question over the saliva composition and functions usually come in the university examination. Okay. Now next we're going to discuss about the main function of saliva. So in function of saliva, the saliva perform various functions like digestion, mucosal integrity maintenance, then oral pH buffering, teeth mineralization, provide sense of taste, and lubrication, antimicrobial activity. But all these functions we're going to discuss in detail. So first we have in functions of saliva. First we have that saliva is responsible for preparation of food, swallowing. Okay, so when food is taken into mouth, it's moistened and dissolved by saliva, and mucous membrane of mouth is also moistened by saliva, and it facilitates chewing. And by the movement of tongue, the moistened and masticated food is rolled into the bolus, and also mucin of saliva lubricates the bolus and facilitates swallowing. Okay, so this is how preparation of food occurs. It will be preparation of food for swallowing. Then next we have another function, that is appreciation of taste. So as we know that taste is a chemical sensation, right? So by the action of saliva, means saliva has a solvent action, right? So saliva dissolve the solid food substances so that the dissolved substances can stimulate the taste bud, and the saliva taste bud recognize the taste. Then next we have the digestion function. So saliva has three main digestive enzymes, like it has amylase, then maltase, then lingual lipase. So salivary amylase is basically, this is a carbohydrate digesting enzyme. Okay. So this is carbohydrate digesting enzyme. And it acts on cooked or boiled starch and convert it into dextrin and maltose, right? So through starch, the digestion starts in the mouth, and major part of it occurs in stomach, because food stay there in stomach for a very short period of time in mouth and a long period of time in stomach. Okay. So next we have the action of maltase. So maltase is present only in traces in human saliva, and the main function of maltase that it converts maltose into glucose. Then another function we have of lingual lipase. So lingual lipase is basically the lipid digesting enzyme, and it is secreted from serous glands situated on the posterior aspect of tongue. Okay. Now another function we have cleansing and protective function. So, due to the constant secretion of saliva, the mouth and teeth are rinsed and cap food for food debris and shed epithelial cells and also some foreign particles. So, in this way, saliva prevents the bacterial growth by removing materials which may serve as culture media for bacterial growth, right? Another thing, that a very important substance that is present in saliva, that is known as lactoferrin. So, lactoferrin of saliva has antimicrobial property. Okay. Then another thing we have is immunoglobulin. So immunoglobulin IgA is also present in saliva, that helps or that has antimicrobial and anti antiviral action. Then another thing we have that saliva has a very important role in speech also. So by moistening and lubrication, soft part of mouth and lips help saliva help in speech. If the mouth become dry, articulation and pronunciation become very difficult. Then another function we have is excretory function. So when we talk about excretory function, so okay, so another function we have is excretory function. So many substances, both organic and inorganic, are excreted in saliva, and also it excretes substances like mercury, potassium iodide, lead, thiocyanide. Okay, and also saliva also excretes some viruses, such as those which are responsible for causing the disease like rabies and mumps. Okay, then another thing we have is regulation of body temperature. So in basically excessive dripping of saliva during panting helps in the loss of heat and regulation of body temperature, and also in when we talk about humans. So in humans also sweat glands plays a very important role in temperature regulation and saliva, and does not play any role in this function. Then next we have another function, that is regulation of water balance. So when the body water content decreases, so at that time, what will saliva do? Saliva secretion also decreases, right? So this will cause the dryness of the mouth, and that process will induce the thirst. Okay. So when water is taken, it quenches the thirst and restore the water content back, right? So this is all about the main function of saliva. Now next we have the regulation part. So when we talk about the regulation, so here we're going to discuss about the reflex regulation of salivary secretion. So when we talk about reflex regulation, so saliva secretion is regulated by a nervous mechanism through reflex action. In that, first we have unconditioned reflex, and second we have conditioned reflex. Okay, so unconditioned reflex is basically the inborn reflex. Means that is present since birth, and also it does not need any previous experience. Okay, so this is an inborn reflex, so no memory is needed, basically no previous memory. So this reflex induces salivary secretion when any substance placed in the mouth, and it is due to the stimulation of nerve ending in the mucous membrane of the oral cavity. Okay, so here previous experience not needed. Right now, next we have the condition reflex. So this condition reflex is the one that is acquired by experience, and it needs previous memory. Previous experience will be needed. Okay, so this is acquired by previous experience. Okay, so presence of food in the mouth is not necessary to initiate this reflex. The stimuli for this reflex are the sight, smell, hearing, or thought of food. So by just listening about the food, or seeing the food while doing anything, or by smelling the food, the salivary secretion immediately starts in the mouth. Okay, so this is all about the regulation. Next we have the composition of sulfur centricus. Okay. So as we know that succus centricus is secreted by small intestine, right? So here we're going to discuss about the main properties of succus centricus. So talking about the properties, so the volume of succus centricus is 1800 ml per day, and the reaction is alkaline and pH is about 8.3. Now, talking about the composition, so Succus centricus has 99.5% water content and rest 0.5% it has solids. Okay. So then in solids also, the organic and inorganic substances are there. In organic, the enzymes are there like proteolytic enzyme, amylolytic, lipolytic, and a very important enzyme that is known as enterokinase is there. Then in other organic substances, mucus, intrinsic factor, and defensins are there. And in inorganic substances, some very important substances like sodium, calcium, potassium, bicarbonate, and chloride and phosphate, sulfate is there. Then next, we're going to talk about the function of succus centricus. So whenever we talk about the function of succus centricus, the very important we have is digestive function. So, the enzymes of succus centricus that act on partially digested food that is present in small intestine, right? So that occurs that act on partially digested food and convert them into final digested product. Okay. So enzymes are produced and released into succus centricus by the cells that are known as enterocytes of the villi. So some enzymes we're going to discuss. First we have proteolytic, then amylolytic is there, right? And finally, we have lipolytic. So, proteolytic enzymes that is present in succus centricus are peptidases, and these peptidases convert peptides into amino acids. And as the name suggests, amylo. So, amylolytic enzymes are responsible for for the digestion of carbohydrates. Okay. Then lipolytic enzymes, as the name suggests, lipo. So lipolytic enzymes are responsible for the digestion of lipids. Okay. Then another function we have is protective function. Okay, so mucus that is present in succus centricus protects the intestinal wall from acid chyme which enters the intestine from stomach. So thereby it prevents intestinal ulcers also. Then as we have discussed, there is a presence of defensins. So defensins are there. So defensins and lysozyme enzymes secreted by Paneth cells of intestinal gland have antimicrobial activity and they will always inhibit the growth of the bacteria. Okay. Then another function we have is activator function. So as we have discussed, a very important enzyme that is present in succus centricus was enterokinase. So enterokinase present in intestinal juice that activates trypsinogen to convert into trypsin, and trypsin in turn is responsible for the activation of other enzymes. Okay. Then next we have hematopoietic function. So basically, there is a very important substance that is present, that is intrinsic factor of Kessel. So that is present in intestine, which play a very important role in erythropoiesis. How it will play? Because this intrinsic factor of Kessel is very important for the absorption of vitamin B12 in intestine. And finally, we have the hydrolytic process. So the intestinal juice is also responsible for in enzymatic reaction of digestion. Okay, so this is all about the function of succus centricus. Now next we're going to discuss the digestive enzyme of succus centricus, and in that first we have the various enzymes. Enzymes are there. Then substrate is there, and end products. Okay. So in enzymes, first enzyme we have is peptidase. Then we're going to discuss about sucrase, then maltase, lactase, then dextrinase, and finally trehalase. So the enzyme peptidase is responsible for the digestion of peptides. And end product we have is amino acid. Then sucrase will act on sucrose, and here we receive a final product that could be fructose or glucose. Then maltase is responsible for the digestion of maltose and maltriose. And here we receive the end product again, that will be glucose. Now, lactase is responsible for the digestion of lactose. And here the end product can be galactose or glucose. Then we have the another enzyme, that is dextrinase, that is responsible for the digestion of dextrin, maltose. And again, we receive the end product, that is glucose. Then finally, the last we have is trehalase, and here the substrate is trehalose, and again the end product is glucose. So the main function of all these enzymes to convert these substances into the more soluble product so that the absorption can be occur easily. Okay. Now, next we have the another important topic of GIT, that is function of large intestine. Okay, so when we talk about function of large intestine, so in large intestine is responsible for the function like digestion, absorption, elimination, maintaining electrolytic balance. Then another function is that this is also responsible for formation of feces. Right. So when we talk about digestion, so the intestine is responsible for breaking down food into smaller molecules that can be absorbed into the bloodstream easily. And when we talk about absorption, so intestine absorb the nutrient from the digested food and transport them to the liver, and where they are processed and get stored. Okay. So intestine play a very important role in the absorption of various substances like water, electrolytes, organic substances like glucose, alcohol. Okay. Then elimination. So elimination means excretory function. Okay. So large intestine excretes very heavy metals also like mercury, lead, bismuth. Okay. And intestine also eliminate waste product from the body, including undigested food, bacteria, and some toxins also. Then maintaining electrolytic balance is another function of large intestine. So large intestine also eliminate waste product from the body, including undigested food, bacteria, and toxin. And when we talk about formation of feces, so formation of feces is another important function that is performed by large intestine. So after absorption of nutrients, water, and other substances, the unwanted substances in the large intestine form feces, and that is excreted out, right? So another thing, that large intestine secretes a very important substance that is known as intestinal juice. So when we talk about the composition, so again, it has water, that is 99.5%, and rest it has solids, that is again 0.5%. So in solids, it has both organic and inorganic. And in organic, it has albumin, globulin, mucin, urea, and debris of epithelial cells. Then in inorganic substances, again it has sodium, calcium, potassium, bicarbonate, then fluoride. Okay, so these are the substances that is present in inorganic. And when we talk about the function of this large intestine juice, so large intestine juice is responsible for neutralization of acid, and also this is responsible for providing lubrication activity. Okay, these are the function of large intestine juice. So neutralization of acid, basically that strong acid that is present in large intestine that is formed by bacterial action in large intestine are neutralized by the alkaline nature of large intestinal juice. Okay, because the pH of this large intestine juice is alkaline, that is about 8. Okay, then another thing, lubrication activity is there because mucin is present. As we can see, mucin is there. So mucin present in the secretion of large intestine lubricates the mucosa of large intestine and the bowel content so that the movement of bowel is facilitated. And mucin also protect the mucous membrane of large intestine by preventing the damage caused by mechanical injury or chemical substances. Okay, so this is all about the large intestinal juice. Now next we have the another important topic, that is phases of deglutition or swallowing. Okay, so what is this deglutition? So this is the process by which the masticated food moves from mouth into stomach through pharynx and esophagus. Okay, the pharynx and esophagus both are the structure that is involving in the process of deglutition. So here we have 3 main stages. First we have the oral stage. Then second we have is pharyngeal stage. Then third we have is esophageal stage. So as the name suggests, oral. So here the food moves from mouth to pharynx. Then in pharyngeal state, here the food moves from pharynx to esophagus. And finally in esophageal stage, the food moves from esophagus to stomach. Okay, so one by one we're going to discuss about all these stages in detail. So here the first stage, that is oral stage, is voluntary. Okay, so this is a voluntary stage, and in this the food passes into stomach from mouth into pharynx by means of series of actions. So what are those actions? So as we can see in this first stage, so here what happened, the bolus which is placed over the posterior dorsal surface of the tongue, that is known as the first preparatory stage. So here the anterior part of tongue will get retracted and depressed, and posterior part of part of tongue is elevated and retracted against the hard palate. So in this way they will be this will push the food bolus back into the pharynx. Okay, then forceful contraction of tongue against the palate produces a positive pressure in the posterior part of the oral cavity, and finally in this way, with the help of tongue, the food will go from mouth into the pharynx. Okay, now next we have the another stage, that is pharyngeal stage. So as we have discussed, first of all, this is the involuntary stage. And here the food moves from pharynx to esophagus. Okay, and what happens in this stage, basically it has in pharyngeal stage, it is a involuntary stage, and in this stage the food is pushed from pharynx to esophagus. And as we know, the pharynx is a common passage. It is a common passage for both for food and air, and it divides into larynx and esophagus, as we can see in this picture also. right? So what happened in this stage, due to various coordinated movements are present, so bolus is made to enter into esophagus, and entrance of bolus to other part is prevented as follows. So that we're going to discuss. So what are those parts basically that will prevent it? First, we have the back into mouth. So return of bolus back into the mouth is prevented by the position against the soft palate that is present on the roof of the mouth, and also high intraoral pressure is there that is developed by the movement of tongue. Then another thing, upward into nasopharynx. So as the food cannot enter from pharynx to nasopharynx, so movement of bolus into nasopharynx from pharynx is prevented by the elevation of soft palate along with its extension that is known as vulva. And third, the food can also enters from pharynx to larynx. So the approximation of vocal cord that is present, that is prevent the food from move from pharynx to larynx, and also forward and upward movement of larynx is responsible for this prevention. Okay. So esophagus that lies behind the larynx that continues as GI tract. So since pharynx communicate with mouth, nose, larynx during this stage of deglutition, bolus from the pharynx can also enters back into the mouth, nasopharynx and larynx, and also downward into esophagus. So as we have discussed that what are the structure that is responsible for preventing the food from pharynx back to the mouth, nasopharynx and larynx. So in this way, the backward movement can be protected, and finally the food will move from pharynx to esophagus. Okay. Now finally we have the third stage that is known as esophageal stage, and here it has two phases: the primary peristalsis and secondary peristalsis. So as we know, peristalsis is a movement that occurs, that initiates in esophagus and occurs throughout the GIT. So when we talk about esophageal stage, or this is the last stage, and this is the involuntary. Okay. So this is also the involuntary stage. So in this stage, the food from esophagus finally enters into the stomach, right? And esophagus form the passage for movement of bolus from pharynx to stomach. And movements of esophagus are specially organized for this function, and the movements are known as peristaltic waves. Okay. So what are peristalsis? Peristalsis means a wave of contraction followed by the wave of relaxation of muscle fibers that is present in GIT, right? So one by one, we're going to discuss about primary and secondary peristalsis. So primary means when the bolus reach the upper part of esophagus. Okay. So just suppose this is esophagus. So when the bolus reach the upper part of esophagus, the peristalsis will start. Okay. And when the food is present in the upper part of esophagus, so that time it is known as primary peristalsis. Okay. So after origin, the primary peristalsis pass downwards through the rest of the esophagus, and there will be propelling of the food towards the stomach. Okay. And what will happen? There will be development of pressure during the primary peristalsis, and also contraction will be there. That is important to propelling down the food in the downward direction. Okay. So what will happen? Initially, that pressure will become negative in the upper part of the esophagus, and this is due to the stretching of the closed esophagus. Okay. So as we can see, when the no food is present, so that time the esophagus remain very close. Okay. Once the food will enter inside the esophagus, so they will be stretching of the muscle fiber. Okay. So immediately after some time, what will happen? That pressure will become positive, and also it get increased up to 10 to 15 centimeter of H2. Okay. Now, next we have the secondary peristalsis. So this movement will occur just after the primary peristalsis. Okay. So if the primary peristalsis contraction are unable to propel the bolus in the stomach, the secondary peristalsis are there that push the bolus finally into the stomach. Okay. So the secondary peristalsis are induced by the distension of upper esophagus in which the food is present, and after origin, these contraction pass down like primary peristalsis, and also these are responsible for production of positive. Okay. So this is all about the stages of deglutition. Now, next we have the another important topic, that is defecation reflex. So what is defecation reflex? Defecation reflex means the voiding of feces. Okay, so voiding of feces is known as defecation. Okay, and feces is formed in the large intestine and also gets stored in sigmoid colon. Okay, so by the influence of an appropriate stimulus, it is expelled out through the anus. Okay, so this is prevented by the tonic contraction of anal sphincter in the absence of the stimulus. Okay, so as we can see in this process, what will happen? Feces are eliminated by defecation reflex, and how this works. When stimulation, when mass movement of colon will be there, then this will cause a distension of rectum that initiate this reflex, and receptors are present on the wall of rectum. Then afferent fibers are there, that is parasympathetic nerve fibers, and center that is present in S2 to S3 and S4, and efferent fibers are also here, parasympathetic nerve fibers, which causes the contraction of smooth muscle of rectum and sigmoid colon, relaxation of internal sphincter. So as we can see, two types of sphincters are present, internal anal sphincters and external anal sphincter. So as we can see, internal anal sphincter has smooth muscle. So means they will be involuntary. And the external anal sphincter has skeletal muscles, means they will be voluntary. So now we're going to discuss the whole act. Okay, so what happens? So as we can see in this flow chart, we are going to discuss about the reflex of defecation. So this is an act of defecation is preceded by voluntary effort like assuming an appropriate posture. So voluntary relaxation of external sphincter are there, and the compression of abdominal contents by voluntary contraction of abdominal muscles. Okay, so usually the rectum is remain empty. So during the development of mass movement, okay, so if suppose mass movement is there and defecation is reflex is initiated. Okay, so what will happen? The process of defecation, which involves the contraction of rectum, and the stretch receptors are there. Okay, so there will be distension of rectum and there will be activation of stretch receptors. So once the stretch receptor that is present in the wall of the rectum get activated, then they will give signals to sacral spinal cord. So as we have discussed, the central is present in S2 to S2. Okay, so signals to sacral spinal cord will be there, and that will give desire to defecate. Now what will happen? Through pelvic nerve fibers, which carry sympathetic nerve fibers, so there will be relaxation of internal anal sphincter, and if conditions are right, means the person has a desire to defecate, then now what will happen? If the conditions are right, then voluntary relaxation of external anal sphincter is there, that is completely voluntary. And if the conditions are not right, then what will happen? The food will remain stored in the rectum, and the reflex subsides until the rectum is filled again. Okay, so this is all about the defecation reflex. And one more thing is there, that there is a presence of gastrocolic reflex. So gastrocolic reflex is the contraction of rectum that is followed by the desire of defecation caused by the distension of stomach by entrance of food. So it is mediated by intrinsic nerve fibers that is present in GI tract, and this reflex cause only a weak contraction of rectum, but it initiate defecation reflex. Okay, so please remember that this gastrocolic reflex always initiate when the food is entered into the stomach. Okay, so this is all about the defecation reflex, and we have discussed all the important topic of this GIT, saliva composition, function, regulation, stages of deglutition, succus centricus, function of large intestine, defecation reflex, all we have covered. So I hope you all these students find this class more helpful. So thanks for watching my class, and for any doubts, any query, you can connect with us through various social media platforms. So thank you so much.